let's talk about vertical asymptotes and how they are related to limits involving infinity. And if you are a random person on the internet, just scrolling around YouTube, and you want to print the sheet that I'll be using to fill in notes, you can go to this bit.ly link, VA limits, capital V, capital A, capital L, and print that. So let's talk about vertical asymptotes and how they are represented by limits. And so let's say we have a function f of x, and it has a vertical asymptote at x equals c. Well, that vertical asymptote can be represented in a limit in at least one of four ways. And sometimes a combination of these two would actually describe both sides of the asymptote. But one of them would be the limit of f of x as x is approaching c, because we are approaching the location of that vertical asymptote. And let's say we're coming to that vertical asymptote from the left side. So I'm going to draw a vertical asymptote at just some random spot. I'm going to call that c. So there's x equals c. And if you're coming to that vertical asymptote from the left, and I'm going to do it again over here, limit as x approaches c from the left, your function could be doing one of two things. Your function could either be coming in and going up forever as we approach that vertical asymptote, or it could be that your function coming towards that vertical asymptote from the left side could be going down. So who knows what's happening over here, but as I get closer to that asymptote, I could be going down forever. If the function is increasing as you approach that vertical asymptote, we can say that the function is approaching infinity. And if your function is decreasing as you approach the left side of that vertical asymptote, we can say you are approaching negative infinity. And for the same reason, you could be approaching, or by the same token, I guess, you could be approaching c from the right of f of x. And as you approach that vertical asymptote from the right side, you could be either going up, increasing, or you could be decreasing. And so graphically, if I wanted to draw that, so here's my vertical asymptotes at c. So here's c. I guess I need to be technical. Call that c, call that c. All right, so on the right side, I could be coming in from the right, and I could be going up as we approach that vertical asymptote, and then we'd be approaching positive infinity. Or maybe I'm coming down and we're approaching negative infinity. And so the left side will be doing one thing, the right side will be doing one thing, and any combination of two of those could describe both sides of the limit. So that's just generically how an asymptote is represented by limits. And do remember that c is a finite number. We're not approaching infinity on these. We're approaching 2 or 7 or 4 or something like that. So how do you know if a vertical asymptote is going to be present if you're looking at a limit? And so if you're looking at a limit, vertical asymptotes typically happen, and there are some functions that don't look like this, but typically happen when you have a fraction for a function, and there are some trig functions that are the exception, logarithmic functions as well. But if you do your initial substitution, if x is approaching 4 and you plug in 4, and you get, as a result, any number divided by 0, where that number is not 0. So if you have a non-zero numerator divided by 0, that indicates that there is a vertical asymptote at x equals c. And so maybe I need to come over here and indicate that the limit does look like this. I probably should have had this in the sheet. So if the limit as x approaches c, and you are dividing two functions, f of x over g of x, if the initial substitution yields a non-zero number divided by 0, then we do have a vertical asymptote at c. And in these cases, if there's a vertical asymptote, your answer is either non-existent, D and E, or it could be infinity or negative infinity. The only time you would answer with D and E is if you're looking at both sides, or this is at least in my class, if you're looking at both sides of an asymptote, if you're looking at both sides, and one side is going up and one side is going down. And so in that case, if that is C, you would say that the limit as x approaches C from both sides of that function would not exist, because they are going in opposite directions. If both sides are going up, I prefer the answer of infinity. If both sides are going down, I prefer the answer of negative infinity. But do know that infinity is not a real number. So if the answer to the limit is infinity, then does not exist is also technically correct. I just prefer the infinities because they are more descriptive. So if you're one of my students, if you can specify which way the function is going with one of the two infinities, I would want you to do that. Okay, so to determine the best answer, should we answer D and E, should we answer infinity or negative infinity? What we would have to do is analyze the function on the left side and or the right side of C, and we're trying to determine if the function is going to be positive or negative. And the sign of the function would obviously be the sign of the infinity that you answer with. So let's look at a few examples. And I think I only have 3 because the concept is pretty, it's not as complicated as some of the other limiting techniques we've done. So I have limit as x approaches 3 from the left, and I'm looking at this. The numerator is stuck at 5. Now this is going to look really dumb, but 5 is approaching 5. And the denominator, however, is the problem because 3 minus 3, if I substitute 3 minus 3 is approaching 0. So I instantly know that graphically this function at 3 has a vertical asymptote. I'm only interested in the left side of 3. So I'm either going up or I'm going down. And to determine that, I have to determine, is the numerator positive or negative? Is my denominator positive or negative as we approach 3 from the left side? Well, 5 is clearly in positive territory. I'm not worried about 5. 5 is much larger than 0. That's squarely positive. X minus 3, however, is approaching 0. And so I have to think, if I'm approaching 3 from the left side, so we're thinking about numbers like 2, 2.5, 2.8, 2.9, 2.99, 2.999, numbers on the left side of 3, as I plug those into x minus 3, we are approaching 0, but we're coming from the left side of 0. So we're approaching 0 from the left side, and that means we are looking at negative numbers. So my fraction here, this is my brain, little thought cloud, I have a positive numerator, I have a negative denominator. That means that this whole fraction is going to be less than 0, and I would say the answer to this limit is negative infinity. So we have this situation, not that one. So you're analyzing the function to determine whether your pieces are positive or negative, and use that to determine the sign of the infinity. Let's look at this one. X over x minus 5 quantity squared. And this one does not specify one side or the other, but I still am going to do that direct substitution. And as I approach 5, as x approaches 5, my numerator is approaching 5. 5 minus 5 squared is 0. So now, in my mind, I know the answer is either does not exist, it's either infinity, or is it negative infinity? What's happening at this vertical asymptote? And at this vertical asymptote, we do need to look at both sides. So if this is 5, I now need to analyze both left and right. If both sides are going up, then I'll answer with infinity. If both sides are going down, then I'll answer with negative infinity. If they are going in opposite directions, one side is up and one side is down, in that case, the best we can say is does not exist. And so we're going to figure this out by analyzing both sides of 5. So I'm going to kind of create some extra work here. I'm going to look as x is approaching 5 from the left of x over x minus 5 squared. And the numerator is approaching 5. And 5 is clearly positive. The denominator is the issue because 5 minus 5 is 0. 0 squared is still 0. And now I'm thinking, what if I plug in numbers on the left side of 5? That's like 4.5, 4.9. And 4.9 minus 5 is negative. However, when you square that, it becomes positive. So the fact that I'm squaring my denominator means we flip that to positive, and we're actually coming from the right side. This is always a positive denominator, which means the left side of 5 is going to positive infinity. So in my graph, I can come over here and kind of sketch that in. And the right side is going to do the same thing because we are squaring that denominator. So 5 from the right of x over the quantity x minus 5 squared. The numerator again is approaching 5, which is clearly positive. The denominator is approaching 0, but because we are squaring that denominator, that 0 is positive. We're coming from the right side. And we also have infinity on the right side, so both sides are going up. And so I prefer to give the answer here of positive infinity. Does not exist is not wrong. If it's a free response situation, does not exist would not be wrong, but I like infinity because it's a lot more descriptive. If it's a multiple choice question, then they would either have does not exist or they would have the 2 infinities as options. They won't give you both because they are both technically correct, but I do prefer the answer of infinity. And then the last example, oh, by the way, before I do the last example, and then if you did look at left and right separately here and you got different answers, one was positive infinity, one was negative infinity, that's the case where you would say does not exist. So just inject that very quickly, interject that really quickly. Look at number 3 here, and you may have noticed that I changed shirts, and that is because when I originally recorded this yesterday, I made a mistake on number 3. So I'm redoing number 3 and splicing the video together and all that mess. So number 3, we have an ugly equation. We have sine pi x minus 1 over the natural log of x. The ugliness, however, should not stop you from doing that initial step of substituting. You should know that if you plug in 1 for x, we will have sine of pi minus 1. The sine of pi is 0. 0 minus 1. My numerator will approach negative 1. My denominator, the natural log of 1, you should know is 0. So my denominator is approaching 0. And a non-zero constant divided by 0 in the world of limits does tell me that this function, as we are approaching 1, will have a vertical asymptote, and we need to determine now if the left side of 1 is going up towards infinity or down towards negative infinity, and we'll do that by thinking about what's happening just to the left of 1. Well, the numerator I'm not worried about. The numerator is approaching negative 1. That is squarely in negative territory, so I know that I have a negative in the numerator. My denominator, though, if I'm approaching 0, we have to decide if we're approaching 0 from negative values or positive values. And it's a little bit trickier with the natural log of x, because if you are a numeric thinker and you don't have a scientific calculator or graphing calculator, which this would be a non-calculator question in AP Calculus, you have to decide if something like the natural log of 0.9 or 0.8, are those positive or negative values? And that's kind of scary without a calculator. But if you can train yourself to think graphically, you should know what the graph of natural log x looks like. So I'm going to graph natural log x, and we're going to think graphically here. You should know that natural log of x has a vertical asymptote on the y-axis. It comes up. It goes through the x-axis at x equals 1, which is why the natural log of 1 is 0. And if you look at the graph of the natural log of x, you can tell that natural log x, as x approaches 1 from the left side, is coming to 0 from below, which means we are coming from negative values in the denominator. So my numerator is negative. We already knew that. We just determined that the natural log of x on the left side of 1 is also negative. That means that the overall answer is going to be positive infinity. We're looking at this situation right there. So there's number 3, and hopefully these vertical asymptotes with limits made some sense for you.